experiment 1B, multiplication and division. The aim of the experiment is to develop an 8086 assembly language program for multiplication and division of two 16-bit data and verify it in the laboratory using microprocessor kit. We assume that the two 16-bit data are stored starting at 300H and the results are to be stored starting at 3010H. So the hardware procedure for the experiment is given here. There are 5 steps of experiment which is common for all the laboratory experiments. In the first step, we assemble the program using the format given here. Then we verify the program using the format given in step number 2. We substitute the data using the format given in step number 3. We execute the program using the format given in step number 4, and finally we display the results using the format given in step number 5. So this is the program for multiplication and division. So before we explain the program, let's see some of the basics about the multiplications, very basics. Let's say for multiplication, when we multiply two 16-bit data which is at AX and BX, when we multiply two 16-bit data, and the results will be 32-bit, which will be automatically stored at AX and DX. So when we multiply 16-bit with another 16-bit, the results will be maximum 32-bit length, so that the microprocessor will take the DX register as extended register for multiplications. That's why we use the DX register here, which is extended register for multiplication and division instructions. Similarly, for divisions, when we take the data, let's say when we want to divide AX by BX, the processor will automatically take DX AX by BX, meaning that the DX register will be taken extended register for division, meaning that the processor will actually do 32-bit over 16-bit. When we say 16-bit by 16-bit, the processor will convert it into 32-bit divided by 16-bit, and the results of the division will be having two parts, as we know. So the remainder part and the quotient part. The remainder part will go to DX register and the quotient part will go to AX register. So this is we should know for division process and multiplications. For multiplication, the results will be at AX and DX. For division also, the results will be at AX and DX. Okay. Now let's explain the program. As normal, so we have 3 instructions here. We call it as initialization instructions. First, we initialize the DX register to 0 because DX register, as we discussed just now, is the extended register for multiplication and division. Then we initialize SA register to point the data locations. Then we initialize a DI register to point the results locations. Okay. Then we have the processing steps. So the processing is, these are the lines for processing. We move the first data in AX, then we move the second data to BX, then we use multiplication and division instructions, multiply BX or divide BX. So then the results will automatically be transferred to AX. So after this process, your results is at AX and DX. But actually we want to transfer the results to the memory location. So these 4 lines are to transfer the results to the memory. So first we transfer AX to the results memory pointed by DA register. Then we transfer DX to the next memory. That's all about the program. Here we have taken, for demonstration, we have taken 111 and 222 as the data for multiplications. When we multiply these two numbers, you will get the results. Actually, the results we will get as 246, 24686 and 42. But for microprocessor, it's the memory architecture is such that it has to store the low byte followed by high byte, as we know very well. So 42 will be stored first, then 86 will be stored, followed by 4 6, then followed by 2. Same thing, we have taken some data for division. Let's say F000 has been taken for the numerator data and 111 has been taken as the denominator. For the divisions, you will get E as quotient and 112 as the remainder. That we will check by simulation as well as in the hardware. Let's see the EMU8086 emulator. Click new, click OK. This is our program. Just now we discussed. We can copy paste the program into emulator. We have to make 3 changes. Change the ORC line. Remove the INT03 hardware interrupt. Change return into HLT. Once the 3 changes are done, we can emulate the program. After view memory, we can see the memory window. The memory you should edit the address to 3000. Now we enter the data for multiplication, that is 111 and 222 as we discussed. Update. Now we can run the program. Once run is completed, we can see the content of the memory. You see the memory has been updated automatically by the program. Now let's see the division process. So change multiplication to division. Emulate. Now we update the memory for division, the data, that is F000, the numerator data, and the denominator is 1111 that we consider. Update. Run the program. Now we can see the content of memory. Yes, 0E is the quotient and 112 is the remainder. The memory has been updated. Now let's see the multiplication in your 8086 hardware. You enter the program using the format. Type all the instructions one by one using the entry key. Now we enter the data using the format SW 3000. The first data is 111 and the second data is 222 that we consider. Now we execute the program, go 2000 and the end address 2030, content of registers and the content of segment registers. Now we can verify the results which is stored at 3010. Yeah, so when we multiply 111 and 222 and the results are 2468642, which is stored in the memory, low byte 42 followed by next high byte followed by next high byte. Now let's see the division program in the hardware. First we enter the program using the format. Enter all the lines of the program one by one using your enter key. Enter the data for division. The numerator we have taken as F000 and the denominator we have taken as 1111. Now execute the program. We can verify the results at the memory using the format. Yeah, so this is the results. E is the quotient which is stored in the first word in the memory, and the remainder is 112 which is also stored in the next word of memory. So the program is, the results is exactly same as that we have performed in the using our calculator. Also same as that we just now done it using the 8086 emulator. So we can conclude in this lab activity we have developed an 8086 assembly language program for multiplication and division up to 16-bit data, and we have verified the same using the given microprocessor kit and also using the 8086 emulator. Thank you.